Welcome back for 6-3 part 2. We are solving polynomial equations. So now we have an application problem here. The amount of photosynthesis that it takes a plant depends on the amount of light present. This model that we have here, this equation that they gave us, is valid only for non-negative x values. So we have to have positive lumens, and also that produce a positive amount of photosynthesis. So we also need to have positive outputs. So our x's and our y's all have to be positive. That means we're only going to be looking at quadrant 1 of this graph once we see what it looks like. So for part A, first thing we're going to do is graph this. So if you could get out your calculator and put this in, or your calculating program, take a look at it. We want to find a good viewing window so that we can see 2 turning points. This is a cubic polynomial, so it can have at most 2 turning points. And this one does have 2 nice ones. So if you could put it in there, see if you can find a good scale. And then pause the video and come back and we'll take a look. So this is the graph that the computer generated for me, but I would probably have a scale from -10 to 10 because I probably wouldn't have messed with that window. And then vertically for the y, maybe -100 to 700, or they have here -200 to 800. That's up to you, but I probably would have had it a little wider. So yours may look slightly different. It's okay as long as you can see both this turning point and this one. All right, part 2. Find the x-intercepts of the graph by factoring. So we are going to use our factoring skills on this equation. 120x squared minus 20x to the third. And we need to factor this and solve it. So if we're solving it, we're putting a 0 here. That's what we're doing when we're solving. Now 120 and 20, do we have any common factors here? We can definitely take a 20 out of that. We want to take out as much as we can. And there is an x squared in both of these equations, so I can take an x squared out. If I take out 20x squared, this would, 120 divided by 20 is 6. And the x squareds are gone, and then minus, and that would be 1x. So there is my factored form, and I have it equal to 0, so I can use the 0 product property. 20x squared equals 0, or 6 minus x equals 0, and I need to solve each of these. I'll start over here with this one, minus 6 from both sides. So I get -x equals -6, divide by a negative, and we get a positive 6. And the other 0 is at, well, if you divide by 20, you still get 0. And if you square root 0, you still get plus or minus 0, which is still 0. So the other intercept is 0. You can also see that on the graph over here. We've got an x-intercept at 0 and an x-intercept at 6. So let's go on to the next question. What is it telling us to do? What non-negative values of x will give positive photosynthesis? Well, we pretty much just figured that out. We need x to be between 0 and 6. If we go past 6, then we're going to get negative output, which is our photosynthesis. So we want for part C, we want our x values to be between 0 and 6. And this time, can they equal that? I think they can, depending on, if you have 0 light, you have 0 photosynthesis. If you have 6 light, you have 0 photosynthesis, lumens. All right, and then part D, sorry about that, went the wrong way. Part D, graph this function with a viewing window that contains only the positive values of x for part C and non-negative values of y. So they just want you to change your window to be from 0 to 6, and then your y window to be from 0 to 7 or 800. Up to you if you want to. The top end of that can be a little bit higher, but the x has to be from 0 to 6, because if we go either direction, we will have some other answers there. All right, one more problem like this. The total cost of producing a product is given by the function c of x here, cost function. This is $1,000, where x is the number of hundreds of units produced. So this is one of those problems where they're taking off some zeros. and trying to make it a little easier to look at. How many units must be produced to give a total cost of $45,000? So what I want to know is, when will this cost function equal $45,000? Well, this cost function, remember, is already in thousands, and x is in hundreds. So anyway, thousands, we're going to put the cost I want to be 45,000, so I don't need to write the 3 zeros because it's already in thousands, equals x to the third minus 12x squared plus 3x plus 9. How many units must be produced? So we need to solve this problem. This one's a little bigger, so let's see. First of all, in order to solve a problem, I want it to equal 0. So I'm going to subtract that 45 off of here. 0. X cubed minus 12x squared plus 3x minus 36. Now we have a problem that has 4 parts. Ignore the equal 0. We're going to take care of that in a minute. We're still going to need to factor this, but we're going to have to use a method that we maybe haven't used in a little while, so I'm going to refresh your memory on that. Got it set up over here. Oh, no, I don't. So we'll go ahead and factor by grouping. So notice there's 4 parts. We can kind of cut it in half, or some people put parentheses around each half. Either way works, and you just look at them separately. So if we look at these first 2 terms, what do they have in common? They have x squared in common. So I can take out an x squared, and that leaves x minus 12. And over here, I can take out a 3, and that leaves x minus 12. In order for the factor by grouping to work, these inside factors here have to match. They do, so I can pull that out. I usually put it in the front. X minus 12 is what I pull out. X squared plus 3 is what is left over, equal to 0. And I want to solve that now. So if I set each of those equal to 0, I have x minus 12 equals 0. That means x is 12. And if I have x squared plus 3 equals 0, and I start to solve that, I'm going to have a little problem here. I have the square root of a negative. So this is going to be an imaginary or non-solution that we do not need to worry about. So answer to this problem, how many units must be produced to give a total cost of 45,000? Is not 12, right? Because x is in hundreds. It's actually 1,200 units. So make sure that you understand what these values up here are telling you about on those problems.